Hello, this is video 8. I've already written stuff on the board. That's because it's in the, not an assignment, it's an example problem. We're going to look at a non-trivial, we're going to spell non-trivial. Non-trivial recursive example. The oil field. O-I-L-F-I-E-L. I don't think they call it that, but I'm going to call it that. Non-trivial recursive example, the oil field problem, which is that 1997 ACM Mid-Central Regional Programming Contest PDF file that I emailed you attached to the links to these videos. This video, it might be fairly short, I don't know, it could be fairly long. I'm just going to try to wade through that description there, which if you haven't read it, you can pause right here and read it. And we're back. Okay, it's got all kinds of terms in it that we're going to have to be able to refer to figure out what the hey is going on when we actually try to do something with it. So I've kind of split that up into the big pieces here. Let me see if I can color code it. They do use the word region. I'll put that small and in parentheses because I don't think that that's really, that's not really an important term for us to keep our minds around when we're trying to figure out what the hey is going on here. The ones that are important to us, or at least to me, so I can keep my mind straight on this stuff, are the plots and the pockets. You might have pockets, which I think I did over there in pink. Pockets are squares within the region that do have oil in them. So this might be a pocket right here. And where else? This might be a pocket right here. And this might be a pocket right here. And let's say it's just 2 columns wide and 3 rows deep. And these that do not, these grid squares over here that do not have oil deposits in them, those they call plots. So that's a plot because it doesn't have any oil. It's all dried up. Plot, plot, like so. So there is my complete grid. I'll do some dotted lines here so it looks more like a grid. But we don't really care about the plots. We're interested in the pockets. Why? Because our whole goal here is not to count the pockets or anything. Oh my goodness gracious, that would be so easy. Anybody could do that. Here's the tricky part. We want to know how many deposits there are. And I'm going to mess up this picture. All of this that I'm circling in ocean blue here, all of that is only one deposit. Why? Because those pockets are connected to each other. They're adjacent, if not side by side up and down, then catty-cornered. We're even going to take the ones that are adjacent to each other that only have one corner in common. We're still going to view those as being connected. And what we want to know is how many different groups of connected pockets are there in the entire region. Which brings me to the last example they put over here, which is 5 by 5, a nice 5 by 5 grid. And I put them in different colors so they stand out. But the stars mean it's dry, it's a plot. So the brown stuff over there corresponds to the brown stuff over here. Those are plots with no oil. The @ signs, those correspond to pockets. You even got to look at the board to remember those words. It's just never going to work. But all the @ signs, each one of those is a pocket. And we take the global view. Here's an example of where the global view can get us in trouble. I can just look at that and see that there are two connected sections of these things, pockets. This one over here, those are all connected. And this one whole column over here, those are all connected. 1, 2, what could be simpler? Here's the difficult part though. If we take a global view, then our temptation would be to implement an iterative algorithm. Iterative, to compare to recursion in a very blunt way, iterative means we're going to loop through it. Recursion means we're going to call a recursive function over and over again to get through it. So either we are going to take a global view and just go through this thing like we're mowing the yard, 1 row at a time, using for loops, probably nested for loops. One for loop will take us all the way across. the next for loop, the next iteration of that would take us all next down. So for I equals 0 to something, inside that for j equals 0 to something, we've done stuff like that, or at least I hope we have. Nested for loops. That would cover it. Here's the problem. First time through, that inner for loop is going to go across this row. And it says, aha, I've seen something. Even if that is a pocket isolated all by itself, that's still a deposit. All I want are the connected regions of at signs. So I know I've seen at least one. And I finish the end of the row, and if I'm keeping count, tally is 1. Here's the thing. Now we go to the next iteration of the outer for loop. Still taking an iterative global point of view. We go to the next row. Oh look, oil. Now here I've got to make it a decision. Is this indeed a new deposit that I've just now struck oil in? Or is it connected to the one I've already seen? And I guess you could say by the time we get to the end of the row, you know what, we've realized, yeah, these two, those are probably disconnected. Those are probably parts of two different deposits. But there's no way to know. Not until you've gone through the whole thing. Let me show you what I'm talking about. Okay, this is one, yeah. That one, you know what? We look up and see, yep, that's connected. So now we've seen two deposits. Keep going through. And suppose that we're happy with life when we get to the end and say, you know what? This iterative algorithm worked. Look at this. There is no rule that says that those had to be dried up plots. Those could be oily pockets as well. Maybe I'll remember that term. That's a fun one. Oily pockets. Let's remember oily pockets. What did I just do? Well, here we go again, iterative. Go all the way through. There's one deposit. This one, well look, there's a plot between oil here and then oil on the last column. So those are two different deposits. I've seen two deposits. And it's not until I get through the whole thing in this fairly simple example that I find out, you know what? This was really one big deposit, all connected. It's an iterative nightmare. I suppose there could be some way to do it iteratively, but I'm not going to go there. I don't want to think about how that might be done. It turns out it's more efficient, it's cleaner, it's more elegant, and more importantly for us, it's easier to do this recursively. It's easier to only take the point of view of one little square in the grid. Let me throw a dart at it. Bonk, I hit this one. You know what? I know that that one is no part of any deposit. That was easy. I hit that, that's going to be a base case. Back out, no oil here. A dry thing, a dry plot. What if, on the other hand, I throw my dart and it lands right here? Oh, that's part of a deposit. How much part of a deposit is it? Well, at this point, I don't know. But what I can do is creepy crawl around me and see if I'm connected to anybody. That's really all I want to do. Am I connected to anybody? And you know what? If I am connected to you, you do the same thing. You do the creepy crawl just around yourself, just in your little local neighborhood there. And surprisingly, that is called the neighborhood within this grid. It's the squares right around the one where we're interested. We will look to see if there's any more oil in the neighborhood. If there is, we will count them as part of us. They will be part of our deposit. So when we get finished creepy crawling around the whole thing, our recursive algorithm will actually find out that there is only one thing, deposit, given the way I've altered this picture. The way it was before, I'll put it back to the way it was. The way it was before, there were two. And the odd thing is, perhaps, since this is taking such a ridiculously local view, it doesn't even matter which square we start at with our recursive algorithm. We are going to be organized about it and always start at the same square every time, but it doesn't really matter. This one is going to creepy crawl around and only find out it's connected to these. That column is only going to creepy crawl around and find out that it's connected to those. That's where we're headed. And now that you've seen this very abstract example, this specific example that they actually have the answer to, the answer is 2. There are 2 deposits in that region. Now we'll get serious about it. We'll roll up our sleeves in the next video and see how the hey we can actually do something like that.